We are now going to present a PV module. What we have here is a polycrystalline PV module. We see that this PV module is made of the following components. It has an aluminum frame which helps on the stability of the PV module. It also has on the front part one crystal which helps to protect the PV cells. So what we have here in blue color are the cells. These are silicium cells, and basically they are the ones that produce electricity. We see also that the PV module has some silver bars. These are called bus bars, and they connect each one of these cells between them. We are now seeing the back part of the PV module. What we see is that it has some sheet protection which protects the cells against degradation. It has in the back part one junction box which connects the cells to two cables. This junction box also has some diodes. The diodes help against shadow so that the power of the PV module doesn't suffer so much when there is some shadow. And we also see that the PV modules have two cables. These cables are made of a special material, solar cable, and there is the positive and the negative, which they have a special kind of connections. These kind of connections are called MC4 connections, and they allow the connection of the PV modules between them in series. They are basically mechanical coded so that it is not possible to connect the positive with the positive of another PV module. This allows only positive with negative connection of the PV module. Whenever we have one new PV module as this one, we need to make sure that there are no physical damage on it. What we are going to take care is in the back part of the PV module, we will check that there are no damage on this protection. There should not be any holes or any kind of burned signs that there is some damage with the PV module. We also want to make sure that there are no deviations on the physical structure of the frame. For example, that we see that it is a little bit with some hits or something that indicates that the PV module fall during transportation. We also will want to check that the junction box was not opened. We see that this junction box has some kind of protection and in some cases some kind of glue, so make sure that there are no signs that this was opened. We also need to make sure that the cabling is in good condition, that there are no cuts in the cabling, and that the connector is in good condition. Sometimes we won't be able to identify if there are some damage on the connectors. We will show you how to do some electrical tests also to detect if there are some damages. For the visual inspection on the front part of the PV module, we will make sure that we don't see any kind of damage on the cells. When I mention damage, this means that we do not see any kind of black points or the coloration points that are noticeable with a simple light. We also want to make sure that there are no cracks on the cells and that there are no cracks on the crystal. Sometimes it is not possible to identify this damage only with visual inspection. There are some special cameras which can detect this kind of visual damages. For us on the field, the most important is to make sure that there are no large damages visible on the PV module before installing it. Whenever you are doing some installation or you are checking some installation, you need to make sure that you have the following equipment to make the following measures. The first system that you will need is a multimeter that will allow you to measure on direct current. This can be any kind of multimeter which can measure up to 1000 volts. The multimeter will allow us to check the open circuit voltage. Make sure that the PV module is in its installation position. You will make sure that the voltmeter will be measuring DC current, and then you simply connect the positive with the positive of the PV module and the negative with the negative input of the PV module. You will wait some seconds until the value stabilizes, and then write down this value. This is because even if we cover completely the PV modules, for example with a carton, and apparently it is completely covered, if we measure now the open circuit voltage, we will identify that it is still on a relative high level, and this can be dangerous when managing this PV module. For example, we are going here to show that this PV module, even if it's completely covered, is still producing 23 volts. This means that covering the PV module is no security to operate the PV module once it is connected. This is the reason why it is completely necessary to install whenever you are working with PV modules connected in series. You need to have one DC disconnect switch. In order to measure the short circuit current, we are going to use one amp meter. We recommend this one that you can open and close so that you can put the cables between this amp meter, and it is really important that it should be able to measure direct current. Some amp meters are only capable of measuring AC current. So take in mind, DC current is important for this tool. In order to measure the short circuit current, make sure that first you connect the positive and the negative of a single PV module. Do not connect the positive and negative of several connected PV modules. This is really important to avoid accidents. So you connect from a single PV module, positive and negative, until it makes one click, and now you have a short circuit on the PV module. So what we are now going to do is, with your amp meter, you put in the position of measurement of DC current, and then you simply put the amp meter on the cable and write down the value. Remember that this value varies depending on the amount of irradiation that you have at the moment. The value on the PV module of the short circuit current is 8.9. We will connect the PV module. It is facing directly on the sun, completely sunny, and now we will check 9.2. This value is okay, it's really close to the value on the PV module. The PV module is not facing directly on the sun, so we will connect and we will check the current, and the current is 0.29 amperes. This means there is almost no production. The PV modules should be facing directly on the sun to have high current. Irradiation has a direct effect on the current of the PV module. Shadow will reduce dramatically the current on the PV module. Here we see that currently this PV module is producing 9 amperes, and we will cause one shadow on the PV module, and even though the shadow is only covering the half of the PV module, the current reduces to 0 amperes. So we should avoid having shadow completely on the PV modules.